The next topic in our linear relations unit is slope. Slope is a really important concept in this unit because it is one of the first or fundamental building blocks that is going to help us in understanding how to write the equation of a line or of a linear relation. So first we're going to talk about what slope is and all the different ways that we can calculate it, and then we will go through very specific examples that use each method. So slope is the measurement of the steepness of a line. So if we have a line that we graph and it is slanted, we can actually calculate how slanted or how steep that line is. And the symbol that is used in algebra or in mathematics for slope is a lowercase letter m. There are three different ways that we can calculate slope, and I'm going to talk a little bit briefly about each of these different methods and when they are best used. So the first formula that we can use to calculate slope is m equals rise over run. Or this could also be read as slope is equal to the rise divided by the run. We're going to talk about what rise means and what run means in a few minutes, but just know that rise over run is best used if you are given a graph. So if you have some data points plotted onto a Cartesian plane and joined together with a straight line, and then you then wanted to determine the slope of that line, this would be the best formula or best method to calculate the slope. Another way that you could calculate the slope is using this formula. M equals delta y divided by delta x. So the triangle symbol that you're seeing there, that is a Greek letter from the Greek alphabet, and it is called delta. Delta means the change. So really what we're doing when we're calculating slope using this formula is we're taking the change in our y coordinate and we are dividing it by the change in our x coordinate. So this formula is best used if you are given a table of values. So remember, a table of values is a chart or a t-chart that has two columns, and all of your data points or all of your coordinate points are listed in that table. The third formula, or the third method to calculate slope, is one of the best known methods to calculate slope, and it is actually referred to as the slope formula. And the formula is m equals y2 minus y1 divided by x2 minus x1. So what the letters x and y represent, again, are coordinate points. So this formula is best used if you are given two coordinate points. And we'll talk about how to use those points and how to label those points and where those subscript numbers 1 and 2 are coming from. Before we begin our examples, there's just some signs that we need to review. So in our first lesson on scatter plots, we did talk about sign conventions, and we said that anything that is moving in a right direction or a rightwards direction, that's always associated with a positive number. And when we are moving towards the left, that is typically associated with a negative number. Same thing if you are counting units in an upward direction, that is always associated with a positive number. And if you are counting units in a downward direction, that is associated with a negative number. So those sign conventions still apply here when we are going to be calculating slope. So just take note of the fact that when we are looking for the rise, we are counting in an upward or downward direction. If we're counting in an upward direction, we're going to assign a positive value. If we're counting in a downward direction, we're going to assign a negative value. When we are determining the run for our slope, you are either going to be counting in a right motion or direction or in a left motion or direction. And again, if you are counting or moving towards the right, that's going to be associated with a positive number. If you are counting units or moving in a left direction, that's going to give you a negative number. Okay, so let's start by calculating slope using our first method. So that is m is equal to rise divided by the run. So example number 1 says to look at the following diagrams, which represent 3 different ski hills. You are to calculate the slope of each ski hill and then rank the hills in order of their steepness from least to greatest. So if you were given a diagram like this, it is really easy to use the formula for rise and run. So before we input numbers into the formula, let's actually talk about what is a rise and what is a run. So when you think of something that is rising, okay, that means something is moving upwards. So rise values are always going to be the vertical portion of your picture or of your object or even on a graph. A rise is always associated with a vertical line or a vertical direction, so something that's either moving upwards or downwards. If you think of running, okay, you have to run in a horizontal direction. So if you're running on a sidewalk, you're either running to the right or to the left. So on your picture, on your object, okay, your run is going to be something that is running horizontally. So something that's running in a right direction or in a left direction. So we'll start by calculating the slope for ski hill A. So our formula is m equals rise divided by run. So on my object or on my picture, the rise would be 60 meters. And I'm going to divide that by my run, which is the 70 meters. So if I take 60 and divide it by 70, I roughly get about 0.86. I'm going to choose to keep 2 decimal places. So 0.86 is the slope of ski hill A. I'm going to do the same thing for hill B. So slope is equal to rise divided by run. So for hill B, my rise is 60, but my run this time is 110. So I'm going to do 60 divided by 110, which works out to be 0.55. And lastly, for hill C, we're going to plug in the numbers for rise and run. So for hill C, my rise is 80 and my run is 100. So if I take 80 and divide it by 100, I'm going to get 0.8. And now we can compare the hills and rank them in order of steepness. Okay, so if we take a look at our answers for slopes, we have to rank the hills in order of steepness from least to greatest. So in terms of which is the least steep, we are looking for the value of slope that is the lowest. So between 0.86, 0.55, and 0.8, ski hill B would be ranked number 1. That is the least steep. 0.55 is the smallest of those 3 numbers. The next then would be hill C, coming in at 0.8. And then the steepest would be hill A. It has the highest slope value at 0.86. Example number 2, a hill rises 2 meters over a horizontal run of 8 meters. A second hill rises 4 meters over a horizontal run of 10 meters. Calculate the slope and determine which is the steeper hill. So I'd like you to pause the video at this point in time and try and see if you can calculate the slope for each of these 2 hills. You're doing the exact same thing as we did in example number 1. We're going to use the formula slope equals rise over run. So pause the video. When you feel like you've gotten a solution, you can hit play again and then see if you've gotten it correct. Okay, so if we were to take the numbers that were given to us in the question and plug them into our slope formula, for hill number 1, my rise would be 2 meters and my run would be 8 meters. So I'm going to be doing 2 divided by 8. So if I do that division, you should get an answer of 0.25. For hill number 2, the rise is 4 meters and the run is 10 meters. So if we do 4 divided by 10, you should get 0.4. They then asked you to determine which is the steeper hill. So again, you're going to look at your answers for slope, and if something is going to be steeper, it has to be the larger number. So between 0.25 and 0.4, 0.4 is the larger slope value. So hill number 2 would be the steeper hill. We can also use the rise over run formula if we are given a graph. And as I mentioned on the first page of our notes and of our lesson, the rise over run formula is best used if you are given a graph. So I'm going to explain to you how you can use that when you are given points that are plotted onto a grid. Okay, so you can see here on this little grid that we've got 2 points plotted. One is point A and one is point B. So when you are given a graph, you may not always have 2 points like we have here. You may be given multiple points, like could be 4 points, 10 points. But really what you want to do is you want to pick 2 points to focus on. It doesn't matter which 2 points you pick, but you can only focus on 2 points at a time. So we have 2 points here, points A and B. So what you want to do is draw yourself a triangle between those 2 points. And I chose a red highlighter, but I don't think you can really see it. So I'm going to go over it a little darker here. So I'm going to draw myself a triangle that connects between points A and B. Okay, so again, like we mentioned, your rise is always going to be running in a vertical direction. So that means that my rise would be located here on the far right. And the run is always running in a horizontal direction. So the run is going to be at the bottom of your triangle. So the next thing that we're going to do is we're going to begin by counting units. So for the rise, I want to count from corner to corner. So the first thing, before you even start counting, you need to check and see what your scale on your X and Y axes is counting by. So if I look at the scale on my Y axis, I can see that it is skip counting by ones. So I'm going to start at this bottom corner here that I've marked with a red dot, and I'm going to skip count upwards. So 1, 2, 3. So my rise is 3 units. I'm going to do the same thing on the bottom for my run. I'm going to start at the corner, so here where I've placed this blue dot, and again, on my x-axis, I'm going to check the scale, and I see that it is skip counting by ones. So when I count my units for my run, I'm also going to count by 1. So I'm going to start at the corner, and I'm going to count 1, 2. So my run is 2 units long. So now that I know my values for rise and run, I can take those numbers and input them into my equation. Okay, so my formula is m equals rise divided by run. So my rise, we counted it out to be 3 units, divided by my run, which is 2. So we are going to do 3 divided by 2. Now, it does work out to be a nice decimal. It is 1.5, but in this particular unit, we are going to keep all of our slopes as fraction values. And we're going to talk about why that is later on in the unit, but for right now, we are going to keep our numbers as fractions. So that means that our slope is going to be written as 3 over 2. So in example number 4, we're going to do the exact same thing. We're going to take the data points from our graph and calculate rise and run, and then use those numbers to determine the slope. But at first glance, when I'm looking at this graph, there is something visibly different compared to the graph that we used in example number 3. And what I notice is that this graph is sloping or slanting downwards. Okay, so it looks like it is falling in a downwards direction. So if you're unsure of how to tell whether something is moving upwards or moving downwards, you always want to be scanning your page or your graph from left to right. So if you have a pencil or a pen and you kind of put it down on the leftmost corner or side of your page and then slide it to the right, you can kind of follow the direction of your graph. So I have this little lightsaber that should be showing up on the screen. I'm going to use this kind of like as a reference pointer. So if I put my lightsaber on the left side of my page, okay, and I scan from left to right, I can see that the trajectory of that blue line that is graphed on the grid, it is going downward. So I kind of have to follow it from point C down to point D, and then I get to the right side of my page or the right corner of my page. So why do we care if the line is a positive direction or falling in a positive direction or running in a negative direction? If your line is running in a negative direction, like it is in this particular example, that means your slope is going to be negative. And the reason that has to do with how we're going to assign a value to our rise. Because remember we said if something is moving in a downwards direction, that is typically associated with a negative number or a negative value. So same like before, I'm going to draw a triangle that connects between my two given points, so points C and D. So there we go. And then again, before I start counting units, I'm just going to quickly look at the scale on my X and Y axes. They are again both counting by ones. So I know that when I count the boxes on my grid, I'm going to be counting by 1. So I'm going to start with the rise. Okay, so it doesn't matter if you start from the top corner where point C is, or if you start on the bottom corner, which is where I'm going to start. I'm putting a big dot there for you to see. So I'm going to start from that bottom corner, and I'm going to count how many units my rise is. So from end to end, I have 1, 2 units. So my rise is 2. Okay, but my line is moving or falling in a downwards direction. It is slanted in a downwards direction. So this is not just a rise of 2, it is actually a rise of -2. So we have to assign a negative value to our rise. We're going to do the same thing with the run. We're going to count how many units we have. So again, I'm going to start from this corner here that I'm coloring in with a blue dot. And I'm going to count from corner to corner. So this is 1, 2, 3 spaces, or 3 units. So this time my run is 3. Now, I know before we said that a run can either be moving towards the right or towards the left. But in math, to keep it really, really simple, we say that the run is always going to the right. So we're always going to keep our run as a positive value, okay? But your rise can either be positive or it could be negative. So keep those sign conventions in mind. It's going to make it a little bit easier for you to read the graphs coming up as well. So rise will be a positive value if your line is slanting upwards. Your rise will be a negative value if your line is slanting downwards. Your run will always be designated as a positive value. So same like before, we're going to take our values for rise and run and we're going to input them into the formula. So we counted our rise to be -2 and our run was 3. So -2 divided by 3, it's not going to give us a really pretty decimal. And like I mentioned before, all of our answers have to be kept as fractions. So my slope for this line is just simply going to be -2 over 3. And I can't reduce that, I can't put it into lowest terms, so that would be my final answer. So just to quickly summarize, our conclusion about positive and negative slopes: any line that rises to the right or is moving in an upwards direction from left to right will always have a positive slope. A line that falls to the right or is moving or slanted in a downwards direction when you scan your page from left to right, that line will always have a negative slope. Okay, now we're going to look at some special cases. So how do we find the slope of lines that are not slanted at all, but the lines that are completely vertical or completely horizontal? So example number 5 asks you to plot points A and D on the graph provided. You're going to connect the points to form a line segment that we're going to call AD. You need to find the rise and run of the line and then calculate the slope. So I've kind of already pre-filled out my graph or my grid. So I filled in the scale for my x and y axes. I just counted by 1, keep it really simple. And I also labeled the letters x and y on the correct axes. So point A is located at 1 and 1. So I'm going to put a point there and I'm going to label it A. And point D is located at point 5 and 1. So I'm going to put a point there and label it D. And then I'm going to join the points together with a straight line. So I can see that line AD is a completely horizontal line. It only runs from left to right. There is no slant in it whatsoever. So it's just a completely flat line. So if I need to find the rise and the run, okay, normally what I'd have you guys do is I'd say draw a triangle between points A and D. But line AD is completely flat. There is no way for me to join points A and D other than the line that I've already drawn in between them. So there is no rise for this particular line. It is not rising in any kind of way. It's just completely flat. However, there is a run. I can count the units or the boxes or spaces that run horizontally between point A and D. So if I count that out, that is 1, 2, 3, 4 units for my run. Okay, so my rise is going to be 0. It is not rising in any kind of way. But the run we calculated or counted to be 4. So I'm going to take those numbers and plug them into my formula for slope. So my rise is 0, my run is 4, and 0 divided by 4 is 0. So what we can conclude is that the slope of any horizontal line, so any line that is completely flat, it is always going to be 0, which makes sense. There isn't any steepness to the line that we created. It was completely flat and running horizontally. So if it doesn't have any steepness, the slope has to be 0. Example 6, we're going to plot points B and E this time on the graph provided. We're going to connect the points to form line segment BE. We'll determine the rise and the run, and then we'll calculate the slope. Okay, so if I have to plot those points, point B was located at 1 and 1. So here's my point. I'm going to label it B. And point E is located up at 1 and 5. And I'm going to join those 2 points together with a line. So this time I have a line that is completely vertical. It is only moving in an upwards or downwards direction, not horizontal in any kind of way. So this time, when I want to count out my units for rise and run, the only thing that I can actually count out is the rise. This is a line that is running completely vertically, okay? There is nothing happening in the horizontal direction. So to find the rise, it doesn't matter if you start at point B or point E, we're just going to count from end to end. So this would be 1, 2, 3, 4 units for my rise. So my rise is 4, and because there is no run, we're going to assign that as 0. So if we're going to calculate the slope, we're going to plug those numbers in. So my rise is 4, my run is 0. So if you have a calculator with you, I'd like you to put this into your calculator. 4 divided by 0. See what you get. So if you put those numbers in and try to divide them, 4 divided by 0, you should get something that says error or cannot be calculated, depending on what kind of calculator you have. The reason is you cannot divide a number by 0. It just won't logically compute. So in math, when we get something like this, we don't write error. There is a term that we use, and that is undefined. So we say the slope of this line is undefined, okay? Because remember, slope is a measure of how steep a line is, and this is a line that is not slanted, it is running completely vertical. So that's almost like the penultimate type of steepness that you can have. It is at the most or the max level of steepness. It is running completely vertically. So we say that the slope is undefined. So again, in conclusion, any vertical line that you come across will always have an undefined slope. We're now going to move on to method number 2. So the second method for calculating slope, if you are given a table of values like that which is shown on your screen. So the slope formula for a table of values is m equals delta y, or change in y, divided by delta x, or the change in x. So what do I mean by change in x, change in y? So what we're going to do is we're going to focus for right now just on the x column in our table of values. So if I look at my x values, I start at -4 and then I drop down to 0. Okay, actually it's not even dropping down to 0. If we think of a number line, -4, if it goes from -4 to 0, that's actually an increase. It's becoming more positive. So how do I go from -4 to 0? I need to add 4. Okay, we just want to make sure that that's the consistent pattern that's happening with all of the other numbers. So now we're going to count from 0 to 4. Well, to go from 0 to 4, I need to add 4. To go from 4 to 8, I need to add 4. And to go from 8 to 12, I also need to add 4. So my change in x is a positive 4. We're going to do the same thing with our y column. We start at -4 and we go up to -2. So that is an increase of 2. -4 plus 2 is -2. To go from -2 to 0, we're going to add 2. To go from 0 to 2, I'm going to add 2. And to go from 2 to 4, I'm going to add 2. So my change in y is a positive 2. So those are the numbers that are then going to go into my slope formula. So to calculate my slope, it is then going to be 2 divided by 4. I take those numbers that we just calculated and plug them straight into the formula. So 2 over 4, okay, if we're going to keep it as a fraction, that can be reduced and put into lowest terms. It would actually reduce to half. So my slope is half, or 1 over 2. We're going to do the exact same thing for this example B. So if you want to pause the video, try it on your own, and then come back to the video when you think you've gotten a value for the slope. Okay, welcome back. So if we were to look at our x column and we would try to figure out what is the x values skip counting by or increasing by, what you should have found is that they are consistently increasing by 5. If I look at my y column, it's a little bit different. The numbers are actually getting smaller. They are decreasing. So if I start with 10 in my y column and then I drop down to 7, that means I've decreased by 3. And then 7 to 4 is another decrease by 3. 4 to 1 is another decrease by 3, and 1 to -2 is another decrease by 3. So this time, the change in my delta y is -3. So if I take those numbers now and plug them into my slope formula, which is m equals delta y divided by delta x, okay, my delta y is -3, and my delta x is +5. So negative 3 over 5 as a fraction does not reduce into lowest terms, so our answer is just going to stay as negative 3 over 5. Okay, in example 3, same idea. We're going to start by looking at our delta x column, and we're going to try to figure out what's happening in our x. So to me, it looks like the numbers are getting smaller. We're going from 6 down to negative 6, and each time we are decreasing by 3. So my delta x value is going to be negative 3. When I look at my y column, however, it's the same number. It doesn't change in any kind of way. It stays consistently at 2. So that means there is no change. So no change in my y values is represented as 0. So now if I go ahead and calculate my slope and plug those numbers into my formula, I'm going to have 0 divided by negative 3. 0 divided by negative 3 is 0. So a slope of 0, if you remember from the previous section, means that this is going to be a completely horizontal line. So if I were to take those numbers in my table of values and plot them on a grid, it would create a line that is completely flat and completely horizontal. In example D, if I start with my x column, I see that all the numbers are the same. They stay at 3 consistently, and there is no change. So that means for my delta x, no change will be represented by a value of 0. In my y column, if I look at what's happening with the numbers, they are getting smaller, and each time they are decreasing by 2. So my delta y value will be negative 2. So if I plug those numbers into my slope equation, I'm going to have negative 2 divided by 0. But remember, if you were to do negative 2 divided by 0 in your calculator, you would get an error. So this is a line that is going to have an undefined slope. And if you were to plot the points from the table of values onto a grid, you would find that you would get a line that is completely vertical. And vertical lines have a slope that is undefined. All right, we're going to move on to the last method to calculate slope, which is the slope formula. So that was the m equals y2 minus y1 divided by x2 minus x1 formula. That formula is best used when you are given a pair of points and asked to find the slope of the line that would pass through those points. So in the first question here, question A, you are given 2 coordinate points, 4, 3, and 8, 6. So in our scatter plot lesson, we learned that when you are reading coordinate points, the first value is always an x value, and the second value is always a y value. And that is true for any given coordinate point. So it's then up to you. Which point do you want to call point number 1, and which point do you want to call point number 2? So I'm just going to keep it in the order that was given to us. I'm going to call this point 1, and I'm going to call this point 2. Okay, so if I'm calling point 43 point 1, then I'm going to call this my x1 value, and this is going to be my y1 value, because they are x and y values that come from point 1. If I look over at my second coordinate point, 8 would be my x2 value, and 6 would be my y2 value. They are the x and y values that come from point 2. You could totally change the order. You could call 43.2 if you really wanted to, and you could call 86.1 if you really wanted to. It doesn't matter. As long as you follow the order of x being your first value and y being your second value. Okay, so I put the slope formula on the screen. So it's m equals y2 minus y1 divided by x2 minus x1. So we're going to take the numbers that we labeled, and we're going to now input them into their proper spots in the slope formula. So we're going to start with y2. So I'm going to look at my data points, and I'm looking for the point that I labeled as y2. So that is the 6. So that's going to go in first, minus my y1 value. So my y1 value, oops, didn't want to do that. My y1 value is what I marked under 3. So that's going to go in my formula next. So I've got 6 minus 3. I'm going to put in my bar, and then I'm looking for my x2 value. So my x2 value, I'm so sorry, I keep choosing the wrong marker. My x2 value is the one that I labeled under the 8. Let me just fill that back in because I erased it. That's x2. And that's going to go into my formula next. So my x2 is 8 minus my x1 value, which is the one that I put under 4. So I'm going to put in 4 into my equation. So we've got 6 minus 3 divided by 8 minus 4. Okay, so let's actually calculate this. 6 minus 3 is 3, and 8 minus 4 is 4. So we've got 3 over 4. So we want to keep our answer as a fraction. 3 over 4 cannot be reduced into lower terms, so the slope that runs between these two given data points is 3 over 4. We're going to do the exact same thing with question B. We're trying to find the slope that runs between points -1, -2, and 2 and 7. So if you want to try it on your own, you can pause the video here, try to fill out the full solution, and then we can come back to the video and see if you did it correctly. So I've gone ahead and labeled my points. So I chose the first point, -1, -2, to be my x1, y1, and I chose the second point, 2 and 7, to be my x2, y2. So now I'm going to go ahead and plug those numbers into the formula. So seems easy enough, but this time we just have to be very careful with the signs because we do have some values that are negative numbers. So I'm going to start with my y2 value. So my y2 I picked as 7. So I'm going to put in 7 minus my y1 value, which I designated to be -2. So now when I put that number into my formula, I need to be careful. My y1 is a -2. So I'm going to put in -2, but I'm also going to put brackets around it. I'm going to put in the bar, and then I'm going to repeat with my x values. So my x2 value is 2 minus my x1 value, which is -1. So again, same thing. I'm going to put -1 inside brackets. So now I'm going to go ahead and do the subtraction. So 7 minus -2 is 9. Remember, when you have two negatives, we can rewrite that as a positive. So this also is the same thing as saying 7 plus 2, which is 9. And then in the denominator, I have 2 minus -1, which is a positive 3. 9 divided by 3, or 9 over 3, this one actually reduces or divides nicely. It's going to give me a final answer of 3. So the slope between these 2 points is a positive 3.